One of the 5 things that we learned when I say exponential, this is the formula that comes out of your head, right? And then I'll zoom in on this. That's what I did. I remember back in the day. Whoa. And then, those last questions. Oh, by the way, I'll stop the video. Any questions from the homework? I'll cover a couple things. But then I just said, what's P sub 0 stand for? What does that P stand for? Initial what, though? Population. I could change A to a variable that actually has meaning. That's all that changes. And then what's P of T stand for? Population over a specific amount of time. Okay, let's stop the video for a second and talk to third hour about yesterday's homework. Okay, so now we're back. That was fun. Oh, I wish that was on the YouTube. That was a very good experience with third hour here. What's the matter? Again? Yeah, you're like a comedian or something. I don't know what she's saying. All right. So look at this formula. This isn't the one from yesterday, but it's close. Remember what I said about this chunk when we were talking about Columbus? You got to look up here, okay? What did I say what this meant? What did that mean, actually, for like Columbus, Ohio, if that was 0.013 for Columbus? What was that? It's increasing. Like I said, what if this was all gone? What 1 raised to the t? What would that do to this if I raised 1 to the first, second, third, fourth? Would this ever change? No. So what we should understand is that this number after 1, in the case of Austin, means it was growing, and it was growing at a rate of 1.3% if you wanted to turn that into a percent. Per what for Austin? Per what? Per year. That's what that number means. Guys, that's all that this is. This is taking yesterday's formula and analyzing, is this a increasing situation or a decreasing, and what is the rate of increase or decrease? For yesterday's kind of example, although it's not exactly what Austin's or Columbus's was, that's a 1.3% increase. I mean, think about it. If this number was less than 1 raised to it, like 0.92 raised to the t, if I plug in a 1 for here, what happens to this population? It goes up or goes down? It goes down. Okay, so this is a rate of decrease. What's the rate of decrease per year? What do you think? What does this decrease per year? Not 92%. It decreases 8% per year, right? Or 0.08. That's how much you lose. If you have 100 people in this population, what's 100 times 0.92? It's 92. That was not a. I'm sorry. I'm going to get in your face on that. All right? That's 92 is the answer. How many people did you lose? 8. Where'd they go? I don't know. It's sad. All right? By the way, you know the state of Illinois is decreasing so quick. People are running out of this state. They can't get out of here quick enough. You know why? Crooked politicians. Yeah, get this on YouTube. This is the part you should. There's crooked politicians. It's number 50, the number 50th state or 49th state for people to retire in. Did you know that? Okay, I agree. So that means that's bad. So yeah, the rate of decrease in Illinois is horrendous. All right. All right, so this is what we're talking about. And this is why I shoved the first examples in your face with the answers given, because it really shouldn't be a big deal. Okay, so but let's zoom in on this and make it like more powerful. So let's just look at these. Here's San Jose, and yeah, Detroit was a bad town as well. There's pretty bad stuff going on there over the years with lost industry and people losing jobs and all that other stuff. So look at Detroit. Is Detroit increasing or decreasing in population? Decreasing, and that rate, depending on what span of years you look at, is probably a lot worse. All right. What's San Jose doing over a span of years? It's increasing. So I put these parentheses to make this look better. What is the rate of increase for San Jose? 1.36%. What's the rate of decrease for Detroit? What do I have to do to find that? Well, it's not 100. Someone made that mistake in my. It's 1 minus, or actually technically it's 0.98 blob minus 1 because you want it to be a negative, but it's not a big deal. So that's it's not rocket science. All we're doing is just analyzing from the B value. Is this an increasing or decreasing? And then what is the rate of increase or decrease? Actually, is another word is decay. Okay. All right. So I'll stop right there, and you can write. Here's the next one. All right. I just shoved it in, it's just, I mean, come on. All right, determine an exponential function. Stop. Exponential. Okay, it was a times b raised to the x yesterday, but we're analyzing it, increasing at a rate of 8%. That means this turns into 1.08, which I don't know if you need all this, breakdown in order to see that, but there it is for you. So the initial value is 12, whatever that is, and then 1.08 raised to the t. Very simple, right? All right, here we go. All right, now watch this. Suppose a culture of 100 bacteria in a petri dish, and the culture, look at that, doubles, and then what does it say? Every what? The other class I did a better job up to this point about analyzing what is t, and it depends. For our cities yesterday, time was in what? Years, because that's what they said. They had this happened in 90 and this happened in 2000. That's 10 years, so I can do my t in years. What's my t going to be in now? Hours. You got to remember that. All right, this is constructed for hours. I have a question. What is the rate of increase, percentage-wise, if something doubles? It's 100% rate increase. You increase by 100%. But I know you'll get what this means. And by the way, 100% as a decimal is 1. And that's what R is. R is 1. What's 1 plus 1? Good job, class. So you start with 100 bacteria, and okay, fine. Doubling. Look at what B becomes. What does B become? 2. Hey, I forgot to do the second hour because I remember what happens in the book. What's the rate of increase if something triples? No. It's a 200% increase. So, but what do you think this number ends up being if it triples? It does end up being 3 because of 1 plus 2. So I could ask you those tricky questions. Quadruples, what is actually the rate of increase? It's 300% increase, but this B value does end up being 4 for quadruples. And so on and so on and so forth. Okay, but now look at what it says. Predict when the number of bacteria will be 350,000. Where does that really go? Where does 350,000 go so I can solve for this? This is it based off of your 58A and B question. P of t. Now I will say this. The glory and power of logarithms would be able to solve this actually a lot faster than the graphing calculator. But we don't know those enough yet. We will do that when we get to logarithms. I could come back to this question, do it with logarithms, and it would be 10 times faster than doing it with the graphing calculator. No. All right, someone said, can you show us? Do you really want to see it? Okay, fine. You wanted me to show logs, and then I'm done. We don't know logs, let's pretend. So what do? We put this in y2, we put this in y1, and we find the intersect. That's what we're doing right now. But when we get to logs, then you must know how to do logs and make it go faster. Otherwise, you'll run out of time on a quiz, those that use a graphing calculator for every single stinking question because they don't listen to Mr. S. There are people like that. Okay, now I will emulate this on the graphing calculator, which I just closed. This was just a little sketch to save time, because I do believe there are some people that are still struggling with the graphing calculators. How do I set them up and all that other stuff? And then we'll speed up the notes after this. But 100 times 2 carats, and I do have an upgraded calculator, so it throws that, and I don't have t, but you just put x. And then 350,000. And you got to think. Watch when I hit zoom standard. Am I going to see anything? Actually, I was shocked to see the first graph. And then I kind of makes sense. I was shocked to even see this. Why? Well, for the love of whatever you believe in, what does that tell me I should change in my window? I don't know where my calculator went. Did anyone see this ghost of a calculator? What is going? Oh, this computer. Oh my goodness. It's a good thing this is on YouTube. Thank you. Okay. What do I have to change? Why what? I'm already on it. Y max, right? Now I'm going to go to 400,000 because I like going bigger than what. I don't want it right on the top line. If I put 350, it'd be right at the top of the screen. And then when do you think this might happen? I don't know. Do you think it would be done in 10 hours? No, probably not. Doubling every hour? You could double 100 every hour for 10 hours. You're not going to be at 350,000. So you have to have some sort of brain here about thinking about when this is going to happen and then knowing, when I could see these pops. So I just get a guess 50, and if it's not good enough, I'll change it. It's good enough. I see that graph, and I see it intersect with that. And then quite honestly, I went through a struggle of second calculate intersect, of trying to see, it's at x equals 20, that's why already, comma, so it's to the left, that's why it was, but I don't really even need to see, there it is, I found it. So looking here, you don't even need to do this for intersect, you could just press enter 3 times no matter what. Boom shakalaka. So 11.77 what? Hours, she said it. And if I wanted to be real fancy, you could change hours to, or decimal hours to what? Minutes, and that's what I did because I'm fancy. Half-life. Okay, it's right down here. Whenever it's radioactive decay, that means something's decreasing, and it's the time it takes for half of the sample not to disappear, but chemically change into something else. So a common one is carbon dating. Is that what you did in the science classes, carbon dating? And carbon's in all of us. And last hour looked it up. Carbon's half-life is 5,730 years, I think, is what they told me. I thought it was 5,780. I guessed. I was off by 50 years. That means this. When good old Mr. S dies, and we bury his femur in the ground, the femur, is that my femur? No, that's a leg. I pointed at my arm. This is not biology. Leave me alone. All right, what's this thing called? What is the arm thing called? The ulna? What? The cranium? That's my head. Whatever. The humerus. Oh, I like that. All right. Anyway, this arm bone. Let's pretend the arm bone is supposed to have 14 grams of carbon in it when good old Mr. S dies. It's buried in the ground. They pull this femur out. It's still the same femur, it's still the same size, but they analyze the chemical makeup of it, and the chemical makeup only has 7 grams in it. When did they find his arm? How many years later? 5,730 years later. That's what half-life means. So this is important in constructing a formula for this. All right? And those that were in science will be fine. Those that were not, you better pick this up fast. Well, the first one is not half-life of a carbon. This is just suppose the half-life of a certain, we don't even know what it is, radioactive substance is 20 days. Right off the bat, what's T in terms of? No, it's term of days. Okay, but we're going to use that 20. That 20 is important. Okay, now we are going to construct this, but something's going to get affected here. So it's not just T up here. We'll get to that. The science people know what I'm talking about. But what's the rate of decay then for half-life? It's decaying, so it's negative. What's the rate of decay? Negative. What am I losing? How much am I losing of my stuff? No, just half of it. So what's the percent decrease? You're losing 50% of your stuff. So, just in the construction of how we do this for, what's B, it's 1 plus whatever R is, and R is a negative. So, of course, R is half. Just like in the doubling, B becomes, I said R, B becomes 2. For half-life, B is a half. Right? It's really not a hard concept, but I am constructing it in the way this section is presented, let's say. All right, so there are 5 grams initially. Now we got a problem. I can't just put T here. Because how long does it take for this to go, turn half? 20. Okay, so how many grams will I have in 20 days? 2.5. Let's do this. How many grams will I have in 40 days? Think about it. 1 point, you're close, I think you're math. 1.25, right? Half of 2.5. So what this has to be is I have to put days in here. What happens if I put 20 in here right now? Is this 1/2 to the 20th power? Holy cow, what kind of number is that? Really small. So this is what happens, and I'm just going to tell you why. And this is how all half-life questions work. You put t divided by 20 and don't have a conniption fit yet. The reason is, what happens when I plug in 20 in for t now? What's 20 divided by 20? 1. What's 1/2 to the first? 1/2. Sorry, it was wrong. 1/2, and then what's 1/2 of 5? So when I plug in 20, I get 2.5 grams, which is what should happen from just knowing what half-life means in the construction of the question. When I plug in 40, what does this become? What's 40 over 20? 2. That's multiplying by a half twice. That's what 1/2 squared means. So what I'm trying to get you to understand is, why do we do this? Back up to that human example of the disgusting Mr. S's femur buried in whatever. Y equals 14 grams is what I made up, half-life. And then for carbon, it's T divided by the amount of years it takes for it to decay to half. So the bottom is 5730. I love that question. Love thinking about bones in the ground. All right. And then what does it say next? Well, we should have an idea about how many days should this happen after we just talked about. Would it happen in 30 days? Yes or no? Would that be a correct answer? No. Would it happen in 38 days? Is it possible it could happen in 43, 44, 45? Why do we think that's a good answer? Because in 40 days, it should be 1.25 grams, so we're getting close. And that's the people that, are thinking. All right, so again, we could use logarithms, but no, we're going to pretend nobody knows logarithms. So we're going to go to the calculator. All right, and then now, well, that's the last question. This one requires a much different window. Clear. 1, when will it be 1 gram? When it starts off with 5 grams times, I'll just put it in parentheses. I'm going to make it a decimal. A half is 0.5. Caret. Now, if you don't have this this exponent button and it's just a caret, and then you have to have parentheses. I'm still going to do parentheses, even though with that thing up there, I don't need it. It's not going to hurt anything. But those that don't get this option, your calculator's a TI-83. Caret, you need parentheses, x divided by 20. Now, let's think about the window. Is this going to work? A y maximum of 400,000? What should that y maximum be now? 5? I heard someone say 50 maybe. I don't know. 3, right? Because really, how high do I have to go? 1. I got to see y equals 1. And then when do you think this might happen? Well, we just said that it's got to be past 40 days. So 50 days may work. And then I leave these negatives because it doesn't really matter. What I want to make sure is I cover where it intersects. Oh, I should have got rid of that. It's too low down here. But does this work? A little bit. And if I get that little bottom chunk out of there, then I'll just say like -1. It'll look better now. This is how you manipulate a window so your graph looks better for you to look at. Okay, boom, I really see an intersection there. Yeah, almost 50 days. So if I didn't see an intersection, I just have to go back and extend my X window. Second, calculate 5. All I have to do is hit enter 3 times. That's the good thing about the intersect feature. 46.44 what? 46.44 what? Days. And then I got real fancy. 0.44 days is 10.6 hours. Huh? So 46 days and 10.6 hours. We could surmise that this would happen. Okay, here's your homework assignment. We're not doing that. And I don't think we're doing 43, because that's that example that I just skipped over there. And we're definitely not doing 27. And then I'll put that in the calendar now.